Welcome, Swagatam in ffbmd channel, and in the computer learning series, that is learning computer with seeing the beautiful sights of Indian village, natural sights. And first let tell Jai Bajrangbali, Jai Hanuman ji, Jai Sitaram, Om Namah Shivaya, Om Namah Shivaya, Om Namah Shivaya. Om Sri Urja Devaya Namah, Om Sri Urja Devaya Namah. Now, today's in this lecture, I would like to talk about database management system, and in this lecture you will learn the essential parts of its properties and its characteristics of a database management system, abbreviated as DBMS. So let's see first the natural, greeny, beautiful sights of this Indian village, which is near about a Susan town in Sitamarhi district, India or Bharat. So let us start with the definition of data processing. Data is a collection of facts, unorganized but able to be organized into useful information. A collection of sales order, employee time sheets and class attendance cards are few examples. We can manipulate data to produce outputs such as bills, employee salary, slips and student attendance report. This output called information is organized facts that help people to make decisions. Hence, information is data arranged in a order and form that is useful to people who receive it. Next, and processing in general terms. Processing in general terms is a series of action or operation that converts some input into useful output. In data processing, input is data and useful output is information. Hence, data processing is a series of action or operation that converts data into information. It consists of three sub-activities. First, capturing input data, then manipulating it, and finally producing output information. A data processing system consists of resources such as people, procedures, and devices which it uses to process input data for producing desirable output. Hence, data is a raw material of information, and just as manufacturing process transforms raw materials into finished products, data processing transfers raw data into information. Now we see the data storage hierarchy. Data processing deals with operation on data. For simplicity, system designers define these operations on different levels of aggregated data. These levels form the data storage hierarchy of data processing. There are 6 levels which are standard. There are 6 levels of a standard data organization mechanism used in this hierarchy system. Now see this hierarchy system. In the hierarchy system, level 0 contains bit, that is a single binary digit 0 or 1, and the level 1 contains character which is a multiple related bits. That is multiple related bits combined to form a character. It is also called byte. The that is next level, that is second level, contains field and multiple related characters are combined to form a field. Similarly, third level contains record. Multiple related fields are combined to form a record. And the fourth level is file. And multiple related records are called file. And the last level is database, in which multiple related files are contained. So this is the hierarchical system of a database. Now let's see these one by one bits, which is on the first zero level. It is the smallest items of data and is a single binary digit, either 0 or 1. Character, which is on the level 1. A character or a byte is a combination of multiple related bits. For example, cap M, 8 and dollar are characters. A bit is basic unit of primary and secondary storage, and a character is basic unit of human perception. Next, field. A field is a combination of multiple related characters. For example, if we are processing employees data of a company, we may have one field each for employee code, employee name, worked hours, hourly pay rate, tax rate deduction, and etc. Thus, field is a meaningful collection of related characters. It is the smallest logical data entity, entity treated as a single unit in a data processing. Note that a field may sometimes have a single character, such as sex code field may have only value with M or F, cap M or cap F. Now the record, which is on the level 3. A record is a combination of multiple related fields. For example, an employee record has a fields containing data of an employee, such as employee's code, worked hours, name, pay rate, tax rate, deduction, etc. Similarly, a student record has a fields containing data of a student. Hence, a record is a collection of related fields which data processing applications treat as a single unit. Next in the hierarchy system is file. A file is a combination of multiple related records. For example, a collection of employees records of company forms an employee file. Similarly, a collection of all inventory records of a company forms an inventory file. Hence, a file is a number of related records which the system treats as unit. Notice that every record in a file has the same set of field. A key field uniquely identifies each record in a file. Content of the field are unique for every record in the file. For an employee file, employee code field may serve as the key field. Now the last on the database hierarchy system is the database, and it is on the last level. A database is an integration of multiple related fields. A database is an integration of multiple related files. Sorry, field nahi, files. For example, an employee database of an organization may integrate record of multiple employee files, such as employee salary file containing details of salary and taxation information of all employees, employee personal information file containing general information like age, sex, address, etc. of all employees, and employee skill set file containing details of various types of skills of the employees. A database integrates data from multiple files in a manner to minimize data redundancy. For instance, in case of the example above of 3 different employees files, if in each file an employee record contains an employee address field, and if an employee changes his residence, the organization must change the employee's address in all 3 fields. A database requires change in the employee's address only one, because it integrates the 3 files in such a manner that it needs to store an employee's address data only once and makes the same copy available to all applications. In essence, a database is a collection of logically related data elements from multiple files. Now the next topic in this lecture is a standard method of organizing data. A standard method of organizing data. Two standard method of organizing data for data processing applications are file-oriented approach and data-oriented approach. File-oriented approach was traditional method used in early days of data processing. It has been replaced today largely by database-oriented approach. However, several applications dealing with simple and small data set use file-oriented approach even today. Hence, both these methods hence we discuss both of these methods now. Now first see the files oriented approach. In this approach, this method organizes an application data into one or more files, and the application programs processes the data stored in these files to generate desired output. For example, it will be clear. Let it is a customary to use a master file of permanent data and transaction file containing data of temporary nature. For instance, in a payroll application, in addition to containing all permanent details of each employee like name, address, employee code, payment, income tax rate, etc., master payroll file also contains current gross pay to date total and tax paid to date total. Transaction file payroll file contains details of hours worked this month, normal and overtime hours, and if piecework is involved, quantity of goods made. When the user runs monthly cycle of payroll application, the application uses both master and transaction files to generate this month's pay slips and update the master file to make it ready for following month's processing. Now let's see the next topic in this series is database oriented approach. In the earlier we learned about the file oriented approach. Now we see the database oriented approach. In the file-oriented approach of organizing data for data processing application is simple, inexpensive, and usually easy to use it. However, this approach suffers some limitations like this. Limited query flexibility. File-oriented approach organizes records in a file according to a key field. Hence, it can quickly process query based on key field value. However, when the key field is not relevant to desired information, it needs to search entire file. For example, if the key field is employee code in an employee file, and if a user needs to list names of all employees having certain educational background, and application has to search all records to produce this information. If the user needs this information frequently, he needs to create a new file structured on educational background key with a new program to process this file. The second limitation is data redundancy. In file-oriented approach, same data items are often present in many different files. For instance, in the example above of creating a new file structured on educational background key, the new file will also have several data items present in the first employee file. Similarly, let us assume that a bank uses file-oriented approach for storing its customers' data, and it maintains separate customer files. Many data items for a bank customer, such as home address, age, occupation, and identification information, may be present in multiple files. Repetition of same data items in more than one file is known as data redundancy. That is, repetition of same data items in more than one file is known as data redundancy. It leads to increase in cost of data entry and data storage. It also leads to data integrity problem. Now the third limitation in file-oriented approach is data integrity problem. Data integrity in this problem, that is in data integrity, refers to the consistency of data in all files. For consistency, the system carry out any change in data item in every file containing that data item. For instance, in our example of bank maintaining separate customer files for each type of account, when a customer moves to a new address, the bank must update his address field in all customer files containing this customer's records. Integrity of data is necessary to avoid confusion that may result when an application updates one file and does not update the same data present in other files. For example, when an application changes a data item, if it does not update the data item in all files containing the data item, there may be frequent discrepancies among reports which the application produces from different files, causing confusion. And the next limitation in the file-oriented approach is limited data security flexibility. Normally, a file-oriented approach offers file-level data security feature. Hence, it can enforce data access restriction on an entire file only, not on a record or a field of data item. The last limitation to the file-oriented approach is lack of program data independency. In file-oriented approach, an application program usually contains data format statement which define the format of each data field concisely as the application needs it for processing. Since different applications create different files, this often results in different files having same data item stored using different data format. Data dependencies occurs when data is dependent on application. Due to data dependency, whenever there is a need to add, delete or change data format, we also need to change application program. So data dependency problem also cause incompatibility among data files from different applications, due to which we cannot link these data files if such a need arises. Now, these limitation of file-oriented approach, researchers began looking for a better method of organizing data to consolidate activities. Their report resulted in database-oriented approach for organizing data. This approach integrates together data from multiple related files in the form of a database having flowing properties. It makes data independent of application program, enabling user to add, change and delete fields from database without affecting existing program. It provides greater query flexibility. It reduces data redundancy. It solves data integrity problem. It also includes data security feature at database level, record level and even at field level to provide greater feasibility of restricted data access. With this, I would like to end this lecture here. जय श्री राम, जय सीताराम, जय बजरंगबली, ओम नमः शिवाय, ओम नमः शिवाय, ओम नमः शिवाय। जय हनुमान जी की, जय हनुमान जी की, जय हनुमान जी की।